of section 1, we're going to talk about arc length. And so arc length of, we already kind of mentioned it, when we have a circle like that, we know the circumference, and we can go ahead and figure out what the arc length is. And so here's the formula for arc length. S stands for arc length, and we have our central angle theta, right? It always opens up from the positive side of the x-axis, and it opens up, positive it opens up, negative opens down. And you can find this arc length by taking your angle and multiply it by r, your radius. So if I multiply my angle and multiply my radius, I can find that arc length, that distance around the circle, right? So that's how I find my arc length. So that's S, I have my angle theta, and I can always find that if I'm given a certain radius. So we can also switch this around. We can divide by theta, and so we can find our radius by taking our arc length and dividing by theta, or we can find our angle by just dividing by r. And so that's kind of how the very first video is how we found our theta, and we found out that the rounded circle, we know that is 360, and then we can find out that our circumference is 2 pi r, and then if we divide that, that'd be our arc length. So if we take 2 pi r and we divide it by r, we can find our angle right here. Those r's would cancel, and we get theta equals 2 pi, which we know is the same as 360, and so that's how we found that pi is equal to 180 degrees. So we can use this arc length to do different type of problems, so we're going to go ahead and work on that as well. Another big thing with arc length is arc length, our theta, our angle has to be measured in radians, because pretty much throughout the sciences and engineering and into calculus, our angle theta is in radians because it's much easier to deal with in radians. So to find arc length, our angle has to be in radians. So if it's in degrees, we have to convert it, which was the last video. So here we have a circle with the radius. So here's our radius r of 18.20 centimeters. So that means I have 4 significant figures there. And we want to find the length of the arc. So the length of the arc, so that's S, and it's intercepted by a central angle. Central angle is our theta, following the following measurements. So that means that they're going to give us an angle. So they give us this angle right here, 3 pi 8 radians. So that's our angle. And we know our r, so we're going to find S. So S is equal to r times theta. So that is S equals r, which is, what did I say, 18.20. We're going to times that by our angle, which is 3 pi over 8. So we're going to multiply that, and that's going to give us our arc length. So sometimes you can leave it in terms of pi. So I would just take this number and multiply by 3 and then divide it by 8, or multiply by 3/8 and leave it in terms of pi, or I can go ahead and multiply it by pi using my calculator. So if I use my calculator and multiply it by pi, then I'll get this answer here of 21.44 centimeters approximately, because my radians, or my radius, was in centimeters, so that's why this is in centimeters. So my arc length will have that same units. Okay, so if I have 144 degrees, I can't leave it as 144 degrees, so I can't take 144 and multiply by 18.20. So what I got to do is I got to convert this. So I got to multiply it by pi over 180 degrees, because then my degrees will cancel, one on top, one on bottom. I can take 144 and divide that by 180. So here on this second one, I have 144 over 180 and times by pi. And then I'm going to times that. Now I can take this, because now it's in radians, and I can times it by my radius, which is 18.20. And I can just multiply it all out, and I get approximately, for my S, approximately 45.74. Again, it's in centimeters. So that is one way that you can use arc length, and I'm going to show you a few more examples of how you can use that same formula to solve either for r or for theta. So here are a few more examples. Okay, here's some words for you, a lot of words, but it's basically saying when you have the Earth, and if you go ahead and through the equator, you put our x-axis basically, and then through the center would be our y-axis like this. And our central angle is right here, and if we open up this way, our theta, that our latitude will give us what that central angle is. So it's going to give us what that angle is. So if it says, 42 degrees north latitude, right, we can come up, our angle would just go up 42 degrees, and that would be where that city or where that location is around the curvature of the Earth. And then another point is we know that approximately, that we can go ahead and give that the radius of the Earth, approximate radius of Earth, Earth is 6,400 kilometers. So we're going to use that number in order to do a few different examples. And what the examples that we're going to do is we're going to find out how far it is between two cities. So say this city right here has 40 degrees. So we'll go with 40 degrees. 40 degrees north. That city is Reno. So Reno, Nevada. And we have a second city. So this angle of the second city is Los Angeles, and it is at 34 degrees north. So that's LA. And we want to find, okay, what is the arc length, the distance between these two? So I don't actually say arc length, but the distance between these is S. It is our arc length. So S equals theta times R. We know our two thetas, so we can just subtract the two, and that will give me the distance between the two thetas. So 40 degrees. So 40 minus 34, and I get 6, so 6 degrees, and then I can times it by my radius, which is 6,400. And so that's going to give me my distance between those two. And so that distance, a problem, right? I can't use 6 degrees, can I? So that means I have to convert that 6 degrees. So I have to take that 6 degrees and convert it to pi over 180, multiply it by that, and then I can times it by 6,400. Okay, so that means that I can go ahead and convert this. So that is pi over 30. Then I can times it by 6,400, not 64,000. 6,400. And so my arc length, or the distance between Reno and Las Vegas, is approximately 670 kilometers. So that's how you can find the distance between two cities. There's a couple other examples. I'll just do those in class.